This is Bob. Bob watched my previous video and now he has a REST API with NestJS and a conversational model from OpenAI like GPT-4, and he's super happy with it. However, Bob noticed that whenever the application or the machine restarts, all chat history is gone. So today I'm gonna help Bob to persist chat histories from large language models using a MySQL database. Do you wanna follow along? So come and join us. In previous videos, we integrated a NestJS codebase with an LLM model from OpenAI. But as we talked about already, whenever the machine or the application restarts, all chat history is gone. So persisting the chat history in a database is fundamental to allow the model to remember our previous interactions with it. Okay, great. So how this project is going to work? So we're going to have a NestJS API, and this is going to be the finite state machine that represents our application. So initially, we're going to send a message to our application with no chat session ID. Our API is going to have two attributes: the user message, which is required for all interactions, and a chat session ID, which is optional. So on the initial message, we do not have a chat session ID, so we just send the user message. So the application will receive the message, and since it doesn't have a chat session ID, it's going to consider this message as the new message for our new chat interaction. So the application will create a new chat session ID, and then it's going to persist on a database the user message with the chat session ID, is going to interact with OpenAI models, is going to receive the message from OpenAI, and then is going to persist the AI message along the chat session ID locally and on our application and remotely on our MySQL database. And then it's going to return to the user the AI message and the new chat session ID, and then the machine will wait for the next message. So on this state, when we send a new message to the application using the previous chat session ID, now the model is not going to consider this new message as the initial message anymore. Now it's going to be a new message from the same chat interaction. So based on the chat session ID, we're going to continue our interaction, our chat history with the OpenAI model. And then the model will persist again the user message and the AI message locally and remotely on the database, and then it's going to return to the user the new message and wait for the next one. And then we can keep going on this flow forever. But whenever we send a new message with no chat session ID, it's going to consider the new message as a new chat session interaction, and then the model will persist a new chat session ID on the database and return to the user the message with the chat session ID. And if we go back and use the previous chat session ID, not the new one, with our application, we can keep going our interaction that we started previously. This is quite powerful. If you remember well, on ChatGPT, we can have multiple chat sessions with the model, not just one. So with this flow, we can have different interactions using the same LLM model. And that's pretty much it. So let's keep going. Okay, great. So this is the API that we developed previously using NestJS and the ChatCompletionAPI. So what we did so far, we created on previous videos our module using NestJS. So what this module can do is to receive a message, an object message, which basically contains a string attribute, which is the message that we, the user, send to the model. So we send this message to the service, and then the service adds to the chat history manager the human message, and then we send the chat history to the LangChain library, which connects to OpenAI API. So we get the result from LangChain and OpenAI, and then we send the content text. So we add the content text to the chat history, and then we send the content text back to our REST API. So let's make a demonstration here. So for example, here we have one question. What do you prefer, electric or acoustic guitars? So the thing is, if I send a message here, we're gonna have the output from the OpenAI API. I am an AI and I do not have personal preferences, and then blah blah blah. But the thing is, if I ask the model here, what was my last question to you? The model can properly respond to us. Your last question to me was, what do you prefer, electric or acoustic guitars? So the model could remember our previous question because we saved the AI output and the user input in the chat history here that we developed previously. So we have our chat history manager, which can save the user message, the system message, and the AI message. So, and with this, we can create the message list to be sent to OpenAI API. So, but the thing is, if I do the following, if I restart the application, all the chat history is gone. And if I ask the model again, what was my last question to you? So as you can see, when I send the question, what was my last question to you? You will send me some random output like, your last question to me was, what can I help you with today? Which is not what we asked. We asked, what do you prefer, electric or acoustic guitars? But the question itself was gone since we restarted the application. So what we're going to do, we're going to persist all the chat history in a MySQL database. Okay, great. So here I am using Dbeaver to connect to a MySQL database. So I created a MySQL database on AWS RDS. And here I am connected to this database. So what we're going to do here, we're going to create a database here in using our connection, and then inside this database we're going to create a table to persist our messages. So let's do this. So I'm going to create a script here, a SQL script, and then I'm going to do create database. I'm going to call it LLM chat histories. Perfect. So now if I do show databases, some people like to use uppercase for SQL all the time, so it's up to you. But okay, so here you can see our new database, which is the LLM chat histories. So let's use this new database, and then we're going to show tables on this database. As you can see, there's nothing here. So what we're going to do, we're going to use Prisma on our application to persist the chat histories. We're going to use Prisma as our ORM to connect to the database and persist and manage all the chat histories from different sessions. So let's do this. Let's go back to the code and set up the connection. Okay, great. So this is the Prisma documentation, actually the NestJS documentation for Prisma, and this is the Prisma documentation for NestJS. So what we're going to do, we're going to follow these documentations. So since we already have a NestJS application, the next thing that we need to do is to install the Prisma library in dev mode. So let's do this. I'm gonna copy this. Let's go back to our application. I'm gonna stop it here. And then what I'm going to do, I'm going to do yarn add Prisma --dev. I'm also going to increase the font so it's going to be easier for you to read it. Perfect. Let me know down in the comment section if this size is good for you, or if you prefer bigger or smaller in the next videos. So let's keep going. So let me go back to the documentation. Now we need to run the npx prisma init. So let's go back here and then Prisma init. Perfect. So now we have this folder called Prisma with some stuff here. So we need to set up the data source DB, the provider, and the URL for the database. So in our case, we're going to use MySQL instead of Postgres. So let's set up here MySQL, and then we need to set up this database URL in our .env file. So I'm gonna do this. So I'm going to the .env. Actually, I already have here because I was making some experiments. So this is the .env. So basically, I'm going to set up the database URL for our MySQL database. And here we pass the name for the database. Let me check back in Dbeaver if this is the actual name. So the database name here is actually LLM ChatHistories. So let's go back here. Yes, this is correct. This is the same name. So this is the name for our database on MySQL. Perfect. So the next thing that we need to do is to define the schema for our data to be persisted in the database. So to do this using Prisma, we need to define our model here, which is quite similar to protobuf if you have experience using protobuf. So here we pass the I'm going to define a model here called chat message model, which has a ID, which is a integer with auto increment. We're gonna have the chat session ID, which defines the session ID, which is similar to when you go to ChatGPT, and then we have different chats for yourself. So you can have so every user can have different chat sessions using the same model. So we're going to control this using the chat session ID. We have the actual message that we're gonna send to the model, or the AI will send to us. We have the message role, which is a user, assistant, and system, which defines the behavior for the LLM model. And we also have the created at, which is a datetime UTC. So we're going to use this to sort the message list. So since we always want to return the list sorted from the database, so I'm going to use the datetime to sort the list based on dates. Perfect. So this is the model that we're going to define for our application. So the next thing that we need to do, let's go back here to the documentation. Now, what we need to do, we need to run the migration script. So the Prisma will go to the database and create a table for us. So I'm gonna copy this. Let's go back to the terminal, paste this here. Let's see if this is going to work. Okay, great. Let's go back to our database and let's run the show tables command again. So as you can see here, now we have the Prisma migrations, and then we have the chat message model, which is the table which is going to persist our chat histories. So if I do like select everything from chat message model, it doesn't have anything so far. We're going to persist data in this table while we test our application. So let's go back to the code. And now let's set up the code base to connect with Prisma using ORM and the database, and create the repository layer for our application. So the first thing that I'm going to do is to create a new NestJS module, which is going to be responsible to be the Prisma service, which is going to be the base repository for our chat message model repository. So what I'm going to do here, I'm going to do nest g. I'm going to call it base repo module. The name is up to you. Perfect. So now I have this base repo, we have the module, and we actually need the service. So I'm gonna do nestg service base repo. Perfect. So let's go here. And then we need to do a few stuff as it was defined here in the documentation. So we need to extend the Prisma client and implement the own module init from NestJS and the Prisma client from Prisma. So let's do this. So it's gonna be pretty much extends a Prisma client. It's not importing it automatically, so I'm gonna do add Prisma client. So it's going to be the Prisma client, and we also need to import from NestJS common the own module init. So we're going to implement the own module init, and then we need to override the own module init method on module init, which is going to be pretty much the await this dot connect. And that's pretty much it. This is our base repository for the Prisma repositories. Perfect. Now what we're going to do, we're going to update here this module to allow the module to export our new service. So exports the base repo service. Let me do something real quick here. So I'm gonna do base repo service. I'm gonna use a camel case here. Repo service. Don't worry, it's broken. We're gonna fix it. Base repo service. Perfect. So what we're going to do next? Let's go back to our ChatCompletionAPI module, and then here we're going to create a new repository layer. So what I'm gonna call it? I'm gonna call this new service, actually it's going to be the repository. So I'm gonna do ChatCompletionAPI.repository.ts. So export class ChatCompletion repository, and it's going to be a injectable, and then here we need to pass in the constructor private read only the base repo that we created previously, base repo service, which is the class that extends the Prisma client. Perfect. So what we're going to do next, we need to define this as a in our module as a provider. So I'm gonna do chat completion repository. Perfect. Let's go back to the service, and then here on the constructor we're going to pass this new repository here in the constructor. So it's going to be private read only repository, which is going to be the chat completion repository. Perfect. So if you remember well, we have this chat history manager which basically persists the chat history. But here's the thing, if we start to persist everything in this mess in this class, we're going to mess up the chat histories, because different chats would be saved together. So we need to separate and create one chat history manager per chat session ID. So every session ID will have its own chat history manager. We're going to persist an entire chat history per session ID. So what we're going to do to accomplish this, we're going to update here our chat session ID. Instead of having just one chat history, we're going to have a chat history by session ID. So every session ID will have a chat history manager. And besides this, to allow the chat history manager to receive the list which is already persisted in the database I'm going to create a new function here to populate the chat history list based on a previous list. So which is going to be pretty much something like this. So we're gonna have a method to populate the list from a pre-existing list. So I'm also going to create an enum here which defines all possible messages. So the chat message model is actually the model from Prisma. So let's import it here. So basically we're going to receive a message list from Prisma, which is the data that comes from the database here, and then we're going to populate the chat history. This always going to happen whenever we restart the application and then read the whole list from the database, so the model can catch up what we set previously to it. Perfect. I'm also going to update here the constructor. Instead of receiving just one string, we're actually going to receive 2 attributes. So we're going to receive the system message that we defined previously, and then we're also going to receive a initial message list, which is optional, by the way. So we're going to update the constructor inputs to be something like this. So it's going to be a destructured object from this type, which is an optional string and an optional list. And by default, it's going to be an empty object. So if the list exists, what we're going to do is to persist the whole list in this local list that we have here. Perfect. So let's go back to our application. So we're not gonna have this anymore. So instead of being just this dot chat history, is going to be the chat history by session ID. It's going to be an empty object by default. And then in our get AI model answer, we're going to make some changes here. And we're also going to update the input DTO to have the chat session ID, which is an optional string. So it's a string and it's optional. Perfect. So what we're going to do here, I also need to define a method to generate a session ID if we don't have one. So let's create a function here to define a new chat session ID, which is going to be basically a UUID version 4. Perfect. So we have here the version 4 for UUID. Perfect. And then let's keep going. So the chat session ID is going to be this. The chat session ID is going to be the session ID from the object if the attribute exists. If the attribute does not exist, we're going to create a new chat session ID. And the chat history is actually going to come from this object here. So let's define a function to populate and create the chat history manager if it doesn't exist locally. So basically we're going to have a function to create or read the chat history for us if it doesn't exist. So basically it's going to be like this. We're going to pass the chat session ID, and then we're going to check in our object if this chat session ID already exists. If it does, we just return it. If not, what we're going to do, we're going to read the entire chat history from the database in a list. We're using a find all method that we're going to create in the repository. And then with this list, we're going to create a new chat history manager, and then we're going to pass this list to the chat manager. And then we persist this new chat manager using the chat session ID, and then we return it to be used here. So the chat history is actually coming from this new function that we just created, get chat history by session ID. So we pass the chat session ID as an attribute, and then we remove this, we remove this, and we remove this. So now let's define the method to find all messages by chat session ID in our repository. So what we're going to do here is going to be pretty much something like this. So let me import some dependencies from Prisma. This is the chat message model that we just defined here. What we're doing here, find all by chat session ID. We're going to run a select everything from the database where the chat session ID is a session ID that we're passing, and then we're going to sort based on the created at date attribute, which is basically something like this. We're passing a select everything from the chat message model table, chat message model, where chat session ID equals to the session ID that we are passing as a parameter, and then we are order, and then we run the order by created at using ascending mode. This is pretty much the command that we're passing to the ORM here. And that's it. Let's go back here. This is the function that we need so far. And then let's go back to our service. So here we are reading the list, which is a list of persisted message list. And then we send this list to the history manager. Then we save it here by session ID. And then we return it to be used here. But there's something. When we send the message here to the application and then we receive the message from the AI model, we are persisting the response locally. But we need to persist both locally and remotely. So as you can see here, we are calling this function add human message, and then we're calling this function add AI message. But I need a function to persist the message on database. So let's go back here to the repository and create a new function, which is going to be create new chat message. So let's import here the Prisma from Prisma client, and then here we pass the base repo, chat message model, then create. That's it. So let's go back to our service here, and then when we call the add human message, we also need to call the function to persist the message on the database. So it's going to be something like this: add human message, and then we pass the repository, then we pass the session ID, we pass the message, which is the data dot message, and the message role, which is going to be user in this case because it's the user message. So we're persisting the message here. Actually, this is a promise, but I'm not waiting the promise to resolve. I'm just sending the promise so the code can keep going. And then I do the same to persist the AI message on the database. So here is going to be the assistant, and then it's going to be the result. The message is going to be the result.content. And that's pretty much it. Get AI model answer, and then we extract the session ID if it exists. If not, we create a new session ID, which is basically a version 4 for UUID here. And then we extract the chat history manager based on the session ID. So the function is basically checking if the session ID exists in this object, which is basically an object that has the key is a session ID and the value is a chat history manager. So if it exists here, we just return it. If not, we go to the database, we read all the messages with the same chat session ID, and then we send this list to our chat history manager, and then we save this object locally here, and then we return it to be used in our application. So here we persist the user message locally, and we persist the user message remotely on the database, and then we call the function to predict the message using the chat history. We read the AI message here. Actually, let me do something. I can replace this by AI message. And then we persist the AI message locally in our local chat history to be used for the next messages, and then we persist the AI message in the database, and then we return the AI message in our REST API. And that's pretty much it. So let's test our application. Oh, there's something that I need to do as well. Whenever we return the output, we also need to pass the chat session ID. Why is that? So the user can copy the chat session ID. So the user can pass the chat session ID and reuse it for the next iterations for our API. So basically here I'm going to update the get instance method to populate the session ID as well. So here we're gonna pass the AI message and the chat session ID. And that's pretty much it. So let's test our application. Yarn start dev. Something's broken, let me check. Oh, okay, so I need to import here the module. So I need to import in our ChatCompletionAPI module the base repository module. Perfect. Let's go back to Postman. So if I say now, would you prefer electric or acoustic guitars? Let's see. So the model will say, as an AI, I do not have personal preferences and blah blah blah. So we have the AI message, and now we have the chat session ID. So the thing is, if we go back to the database, let's select everything from this data from the table. So here we can see that we have the chat session ID, which is the same for both, and then we have the would you prefer electric or acoustic guitar, and the AI output. Perfect. But here's the thing. Now if I restart the application, I'm gonna stop this, start it again. But now if I copy the chat session ID and ask again, what was my last question to you? If you remember well, we just restarted the application, which means that the chat history manager got lost when we did this. So let's make the question passing the same chat session ID so the model can retrieve the proper messages from the database. So as you can see, what was my last question to you? AI message. Your last question to me was, would you prefer electric or acoustic guitars? So as you can see, the model could properly return all the messages from the database and populate the chat history manager. And that's it. Now you know how to persist AI messages on a MySQL database using NestJS and Prisma. Something else that I want to talk to you about. If I delete this and send again, what was my last question to you? It's going to be some random output because there was no last question to you in this case. As you can see, the chat session ID now is different. So whenever we don't pass the chat session ID, our application will understand this as the first message in our session. And if you pass the session ID, it's going to keep using the same session for the next messages. So now if I do the same, now we have more messages, and then we have 4 iterations, 1 2 3 4 5, actually 4 iterations using one session ID and 2 iterations using another session ID. If I just select distinct chat session ID from chat message model, we can see that we have 2 session IDs on our database. And that's pretty much it. And that's it. Now you know how to persist AI messages on a MySQL database. I hope you liked it, and I see you in the next time.